Okay, welcome back to NECO Physics Past Question Solution Series. We are in question 16D. 16D says a resistor of 500 ohms and a capacitor of 10 microfarad are connected in series across 50 hertz of frequency, 240 volt EMF source. Calculate from figure 1 the reactance of the capacitor and from figure 2 the impedance in the circuit. So this is a question from alternate current. So let's get it done. Solution. So given that the resistor is equal to 500 ohms, then we have the capacitor to be equal to 10 microfarad, which is 10 times 10 raised to power minus 6 farad, and is connected in series across a 50 hertz. So we have frequency is 50 hertz, and the voltage is 240 volts, right? Okay, that is AC source. Okay, now we are asked to calculate the reactance of the capacitor, S subscript C. So that's what we are looking for. So we have this, the formula to calculate this is XC is equal to 1 all over 2 pi FC. So this would be equal to 1 all over 2 pi is given to be 3.14 times 3.14 multiplied by the frequency, which is 50 hertz, then multiplied by the capacitor of capacitance 10 times 10 raised to the power minus 6. So when you do that, you have this equal to 1 all over. So let us multiply this denominator. So when you do this, you're going to end up having 0.00314. Then 1 divided by the answer. That will give us 318.47 ohms. So this is the answer to the first one. That is the reactance of the capacitor. So the next one is to calculate the impedance. Impedance is the overall opposition offered by both the capacitor and the resistor. So we use Z to represent the impedance, which is equal to the root of R squared plus XC squared. So since this is just RC circuit, that is resistor capacitor circuit, there's no inductance. So we have Z will be equal to root of R is 500, so 500 squared plus the reactance of the capacitor, which is 318.47 all squared. So Z would be equal to root of, so what is the square of 500? It was 250,000 plus 318.47 squared. So that's point here, sorry. So when you square it, you have 101,423.1. So then Z would be equal to, so let us add them together, 250,000 rather, plus 101,423.1. That will give us 351 42 3.1409. So you find the square root of the answer. Square root of 351,423.1409. So that will give us 593.062 volts. I hope this is understood. So that is all about this. So thank you for watching. We continue from here in our next class. Please do ensure you help us share for others to benefit from this. Thank you.